Hello, so today we are going to do this problem, which is part of Leetcode daily challenge, custom sort string. So basically we get two strings, we get order and we get string s, and all characters in order are unique. And they were sorted in a custom order. And what we want is to sort s in the same order as the string order, okay? So basically what that means is if a string, let's say, if B occurs before A in order, then we want to sort S so that B also occurs before A. That's essentially what it means. Now, two things. S can contain a letter that doesn't exist in order, so that like D, and in that case we just need to put it at the end of the string for our sorting, like we did here. The other thing is you could have multiple occurrences in S. You can't have it in order, but you can have it in S. So you can have A, maybe three B's, and then C, D, for example. Now in this case, for the sorting, you would have C, B, A, C, B, B, B three times, and then A two times, and then D, right? And then D, right? So basically, if you have the same letter, as long as you respect the order, when the character occurs, you can put all the same occurrences together. Now, you could also have A, in A, it can be A, B, A, right? C, D, in that case, what we would do also is C, B, A, C, B, A, D, right? So that's just a clarification there. Now, if you look at the constraint, the string itself is not too big. S is 200, and the order length is 26 because we have only lowercase English letters. So definitely an oven squared solution, an oven Lagan solution should work. So let's think how we can do this. Well, we just need to sort, but when we are sorting, we need to make sure, let's go, for example, here, okay? So let's say we have this order string, and then we have, this is order, and then we have S, which would be this, okay? So let's write down just the indices here. So here, 0, 1, 2, these are the indices, okay? So basically what this means is, for every letters in S, we need to just sort by the indices, right? Because since C has an index that is smaller than A, C has to be before A. And since B has an index smaller than A, it has to be before A in the sort, right? So if we sort by this here, for example, and of course we ignore D because it's not in the order for now, then what would get? Well, C is the smallest in the indices, so put C first. B is the next smallest. A is the next smallest. So we have this, and then we can add whatever is not in order at the end. And that's exactly what we have. So that's the key idea, basically. Sort by index, sort S by index in order. Then add up characters that are not in order. But there is another way to do this for characters that are not in order. How do we just add them to the end? Well, it doesn't matter the order they are in. So let's say we have X, W, Y. It doesn't matter the order we add these in. Any order would be valid since they are not in order. And the problem here says return any permutation that satisfies the custom order. So what this means basically is we can just give them all the same index, the same basically index in terms of this here, and then have them be sorted in basically whatever order. We don't care. And so what index do we need to give them? Well, we don't want to give them any index that is smaller than index of something that occurs in order, because then that will mess up the order. But we can give them anything at the end, so we can just give them the length of order. So the last, basically like 3, which doesn't exist here, so they will always be at the end. Okay? And that's pretty much the idea here. So let's code it up. So what we need is, we need to, let's call our function custom order, right? And so it gets character C. What's the order? Well, we said we want to get the index of the character if the character is in order. If not, we want to give it as an index the length of the order. Okay, and then we can just sort S using this custom order, right? And now this will give us a list, and so we will need to join it with just empty string to get back a string. So we can just do something like this, okay? And that should be it. So if I run this, submit, it looks good, okay? Now, another way we can do this is if you don't want to do the index function, which is O of n, to make this function O of 1, what you can do is use a map from the character to the index in order. So let's say order map, order index, let's call it. And let's have the character map to the index for this in the enumeration of order, okay? Now in this case, how do we get the index? Well, we can just say order index and get, we can get C, right? But get also has a default, so if it's not in our map like this, then we can return a default value. And so that's what we can do here. We can return this as default if it's not there. So like this. Okay. Okay. Looks like there's a problem. Let's see. Oh, this needs to be defined. Okay. Looks good. Now this function is actually pretty simple, so we can just add it here as a lambda. So we can do a lambda C like that. Get rid of this, and this should be it. Submit, and that passes. Okay. Now in terms of time complexity, this is O of n, O of the length of order. Let's call that O of n. And this here, if we call m the length of s, this would be, so this is actually will end up being constant because order is up to 26 only. Okay, so this is constant. This is O of n log n. Let's actually consider n the length of s. So this is O of n log n. This lookup here is constant. So this is O of n log n. And the join is O of n. So overall, this is O of n log n time in constant space. Not constant space because we are using this extra array, so O of n space. But overall time is O of n log n. So can we do something that is not O of n log n, something maybe O of n solution? We actually can, so let's see how we can do it. So what we can do is we can first just get the counter of occurrences in S. Okay, so what that means is something like we would have for S equal to this, we would have an occurrence of S which would just say how many times each character occurs. So A 1 time, B 1 time, C 1 time, D 1 time. Okay, now how do we get these to be in the order, in the same order as the string order? Well, we can actually just create a string, let's call it just a list of the characters, and we can just go through order, okay? And we can check if this character, so this would be, we'll go through order in the order it is in. So it goes through C first, B, then A. Then for each of these, we check how many occurrences it has in this occurrence, and for the number of that it's there, we just add that to our list. So for example, here we will add the occurrence of S for that character. We will add it the number of times it occurs. So for example, let's say if it was 2 here, we will add it, would add A 2 times. And we do this in the order, in the custom order. And so for example, here we'll add C first, We'll check how many times it occurs. Just once. Let's add it. So it would be sorted just by the way we are constructing it. It would be sorted in the same order as the string order. Okay. Now once we do that, we used it. So we set it to 0. Why do we do this? Well, because remember the D here, which is not in order, we want we want only those that are not in order to still remain with a count so that we can add them again. So first we process those in order, and then we process those that are not. And how do we do that? Well, since we put those in order here at equal to 0, it's whatever is remaining in occurrence of S. And so we can just go through those. So we can just go through every string and we can just add it. Now, for those that are not in S, not in the occurrence anymore, that's because we set them to 0. So this will be 0. So we don't need to care. They won't be added again. And now this contains the list, and we can just join it like here and return it. Okay? So that's the idea here. Just keep track of the counter, go through order in its one by one, and add as the characters occur in this string. And then for the remaining ones that we haven't added yet because they were not here, we just add them. Yeah. So let's put that back up here. And now we can just join this like that. It should work. Let's run. Looks like we have a problem because this is not valid. Yeah, we also need to define the occurrence, which would be just a counter of S. Okay. And we can submit, and this passes. Okay. Yeah, so that's pretty much it for this problem. Thanks for watching, and see you on the next one. Bye.